Alright, so we are going to start talking about algebra, but we're starting with 6.1, which is exponents. So exponents should not be brand new to you because I think y'all started it a little bit in 5th grade. It's super easy, especially with us being able to use these scientific calculators. And so it should be a pretty easy day for you. Okay, first period liked it anyways. Alright, so we're looking at 6.1, your blue notes. Most of these notes are kind of already filled out for you. There's some things I'm going to have you to box in or to circle or make little notes here and there. But most of it's already filled out for you to refer back to. And I would go ahead and write these things down so that when you're doing your homework or IXL assignments, you can go back to them if you need help. Alright, so we're talking about exponents. We have some vocabulary words here. Your first vocabulary word is power. Power is the product. So that's going to be, product reminds us of what? What do we do? Product is the answer to a multiplication. So that tells us that we're going to be multiplying. So here in our example, this whole thing right here is the power. Okay? I also want you to box in the word base. That's important. The base of the power is the repeated factor. So that number is what's going to be repeated, and factor means to be multiplied. The number is being multiplied. So your base is the number that's being multiplied. It's being repeated. I also think of as base equals big. The base is the big number. And here it points to the base for you. See how that 3 is bigger? That is your base. That's the number being repeated. Okay? I would also box in the word exponent. Your exponent of power indicates the number of times the base is being repeated. So number of times. So for example, we have 3 to the 4th power right here. This means the base being the 3 is the big number. That's the number being repeated. And then the exponent tells us how many times it's repeated. So we have 3, 1, 2, 3, 4 times. A lot of people, when they see this, they'll think 3 to the 4th power equals 3 times 4. I need you to write that on your paper. People see 3 to the 4th power, or 3 with an exponent of 4, equals 3 times 4. This is not true. I want you to put a big old X through it. That is not the case. That is not how we read this. We read it as 3 4 times. So 3 times 3 times 3 times 3. Well, what does that equal? You can figure it out. Well, what is 3 times 3? 9. And then times 3 again is 27 times another 3, which equals 81. Okay? 81 is a big difference to 3 times 4. What's 3 times 4? 12. That's a big difference. Okay? So you got to understand the difference. Now, we can punch this into your calculator to be able to do this really quick. So what I want you to do is everybody take your calculator. Everybody take your calculator so you can do it with me. Because if you don't learn how to do it on this calculator, you're going to have to do it the long way, which takes a lot of time and sometimes it's easy to mess up. So if I wanted 3 to the 4th power, I would punch in 3, the number 3. And then there's a mountain button. So on the same row where there's the green second button, I think it's the 4th one down, there's a little mountain button. It looks like that. You see that? You click that, you're going to get a flashing box up at the top of the 3. You see that?
I don't see no mountain, but
Yeah, guys.
And then put your 4. And then hit enter. And what do you get? 81. Alright? So, The calculator does the work for you. If you don't see the mountain button, you need to ask a friend to show you where the mountain button is so you know how to do it. Okay? All right. And also, on your notes, talks about, well, how do I write these as exponents? Instead of having to write this all long out expanded form, we use exponents to kind of shorten it because math people don't like to write a bunch of stuff. They like to keep things as short as possible. So you can take a written out expanded expression and shorten it into an exponent. So if I have 5 times 5, I can shorten that into an exponent because it's just repeating itself. Okay, if the number is repeating itself with multiplication, then you change it to an exponent. My base is the number that's being repeated. So what number is being repeated here? 5. And how many times is it being repeated? 1, 2. So it equals 5 to the second power. All right. Here we have another example. We have 5 to the 4th power. What number is being repeated? 5. How many times? 4 times. So they got 625. So I want you to put in your calculator to see if you get the same thing. I want you to put 5, mountain 4, and see if you get the same thing. 625. So these calculators will help do a lot of the work for you. You just need to understand what is it actually doing. Okay? Any questions on this part so far? Alright, this is the part where you're going to need to fill out. There are 2 fancy words when you're talking about exponents. Squared and cubed. If you see the word squared, it means that you have an exponent of 2. That x right there represents any number. So anytime you have an exponent of 2, that means squared. So if you see the word squared, it means something raised to the second power. Cubed is to the power of 3. And the way I remember that is a cube, okay, something I can hold in my hands, right? It's 3D. Because it's 3D, it has a power of 3. Okay? A square is 2D because it's flat, so it has a power of 2. Okay? Those are some fancy words that you might need to remember. Those are the only numbers that have fancy words. To the power of 4, 5, 6, 7, none of those have a special word. Okay? Only ones that have special words are 2 and 3. Okay? Your notes down there tell you how you can read some of these things. So I have 9 with an exponent of 2. How can I read? What's one way that you can read this?
9 raised to the second.
9 raised to the second power. What's another way?
9 squared.
9 squared. What's another way?
9 raised to
9 raised to the
power of 2.
Power of 2. Okay. How would I read 9 with an exponent of 3?
9 raised to the third power, or 9 cubed, or 9 raised to the power of 3.
When there's a power of 3, though, it's not squared. What is it called? Cubed. Okay. And then 9 with a power of 5.
Would be 9 raised to the fifth power, 9 raised to the power of 5.
Is there any special word that we can use with this one? Squared only goes with what number? 2. Anything besides 2 and 3 doesn't have a special name. So you would read this as 9 to the power of 5 or 9 raised to the fifth power. Okay? Or 9 with the power of 5. Oh, before we move on here. Another thing I want you to add to these notes, okay, somewhere in the margin area that you might want to know is anything with with a power of 0 equals 1. Anything with a power of 0 equals 1. So I want you to test that theory. I want you to make a big number on your calculator. Just type in a random big number.
89.
Okay? And I want you to hit the mountain, and I want you to put a power of 0 there. And hit enter. And you get
What is that?
1. Okay?
You said a power of 0.
Power of 0.
It said the main area. It says the main area. It says overflow area.
1970.
But probably you put too many numbers.
And the 1986.
Alright, so anything to the power of 0 is what? 1. Alright, now flip it over. Alright, listen. Alright, it says write the product as a power. So what I want you to do is I want us to write this as an exponent, and then I want us to answer it to get practice using our calculator. Okay? So how would I write this 2 times 2 times 2 as an exponent?
2 with the
2, because that's the number being repeated, and how many times is it repeated?
3.
So we get 2 cubed, or 2 to the power of 3.
2 cubed.
Does it make a difference if there's a dot or?
No, dots just being multiplied. Alright, so what is this equal then? If I punch this in my calculator, 2 to the third power, what is it equal? 8.
8. And it's say 8 cubed.
No, you'd say 2 cubed equals 8. Alright, number 2, how would you write that as an exponent?
6 power.
6 to the power of 4, and then you would solve it.
12.
2006.
Alright. Number 3, how would you write that one?
8.
Not over 5, 8 to the power of 5. 32,768. Alright, number 4.
10 to the power of 4. And it's 10 to the power of 4.
It's 10 to the power of 1, 2, 3, 4, 5, 6. Now the good thing about powers of 10s that I like, it's just whatever the exponent is, that's how many zeros you're going to have. So 1, 2, 3, 4, 5, 6. So that would actually be 1 million. Alright, number 5.
7.
Equals 1 to the power of 7, which is just 1. Because 1 times 1 times 1 times 1 times 1 is just 1. Number 6.
47.
Not
I mean,
over.
cubed.
27 cubed.
To the power of 3. When you say over, it means a fraction.
Oh.
So 27 cubed equals 19,683. Beautiful. And 3 to the power of 5
Is 243.
and number 8.
65 to the power of 4.
65 to the power of 4, which equals
17,850,625.
850,000. What?
850,625.
Alright. How would you do number 9?
To the power of 6.
It's 4,000.
And how would you write number 10?
7 to the power of or 7 cubes, which is 343.
Well, what does number 9 equal? I'm sorry.
4,096. 0.
4,096. Okay. Not too complicated, right? It's pretty easy. All right. This one, I just want you. You can just solve these. Okay. Just tell me what they equal. So like 2 squared, 4 cubed, 6 cubed. What are these equal? So this is just practice putting them in your calculator. Okay, so that's what I got. So you can check to make sure you got everything. You just gotta pay attention that you punch it into the calculator correctly, and then you should get it. Okay. And then the last part, I want you to write it in expanded form and word form. So expanded means I want you to write it out. So tell me what this means.
4
times 4 times 4, which is 3 times. Okay? And in word form, how would you say
4
this?
to the power of 3.
4 to the power of 3 or 4. How would you write out number 23?
10 times 10.
10
And it
times
is
10.
10 to the power of
You could do 10 to the power of 2 or 10 squared. And then how would we write out number 25? 12 5 times, right? 3, 4, 5. What would the word form be? Alright, 12 to the 5th power, or power of 5. Either way. And then 27, how do we write that?
100.
100 4 times, right? And what would the word form be? 100 to 4 power or power of 4. And that's all you do with exponents. That's pretty much it. One more trick I need to show you. Okay, because you have it on your homework tonight. It's called a perfect square. That means perfect squared means that it's multiplied, the same number is multiplied how many times? Squared means what? 2. So that means the number is multiplied twice. So like if I have 12 times 12, which is equal to 12 squared, right? What is 12 squared? What was 12 times 12? 144. 144 is considered a perfect square because it was made by a square. Okay? So to test to see if it's a perfect square, what you would do is you do 144 in your calculator. All right? You would do the second button, and then you would do, there's a button that looks like this, because over the top of it, there's a little thing like that. That means square root. Okay, that's trying to get down to the original.
And what number?
And then when you hit enter, oh, because what we gotta do, we gotta first, reverse order.
No.
Okay. All right, so first you hit the second, then you hit that button, then you type in your 144, and then you hit enter. And what do you get?
1700.
Well,
All right, type in second,
Second.
then the x squared button, and then 144, and hit enter. And you should have gotten 12. Okay?
you don't put in 144 and then
Listen. Okay. Listen. If you get a whole number, then it's a perfect square. If you get a decimal, it's not a perfect square. Okay? Alright. What you're about to work on right now is IXL D1, 2, 5, and 6. You should get hundreds on these pretty easily. Okay? I have created a new leaderboard. So that is up and running. Your IXL assignments are over. Exact same thing we just did. Okay? It should be pretty easy.